The law of sines and the law of cosines allow you to apply trigonometric functions to non-right triangles. Given triangle ABC with angles A, B, and C, and the opposite side length A, B, and C. The law of sines relates the angle of a triangle to the sides opposite them. It's written as the sine of angle A over the length of A equals sine of B over B equals sine of C over C. When the law of sines cannot be used directly, we turn to the law of cosines. This formula allows you to relate all three sides of a triangle with one of its angles. The square of the side opposite the known angle equals the sum of the squares of the two adjacent sides minus twice the product of those adjacent sides times the cosine of the included angle. In triangle CDE, the length of CD is 8, DE is 6, and the measure of angle C is 30 degrees. What is the measure of angle E? Round to the nearest degree. Start by drawing a sketch of the given information. It's not necessary to try to make your sketch to scale, as you will not be relying on measurements of the sketch to find the missing information. Instead, since you know one side and the angle opposite that side, you can use the law of sines to find a second angle. Sine of 30 over the opposite side, 6, equals the sine of angle E over the opposite side, 8. Isolate sine of E by multiplying both sides by 8. Then reduce. To get the measure of angle E, we take the sine inverse of both sides. Using a calculator, we find that the angle E is about 42 degrees. So you could conclude that the angles in the triangle measure 30, 42, and 108 degrees, since they add up to 180 degrees. However, there's another angle which has the same sine value as the 42-degree angle. Using the unit circle, you can see that 180 minus 42 also has the same sine value. 180 minus 42 is 138. Since 138 degrees has the same sine value as 42, the angles in the triangle could also measure 30, 138, and 12 degrees. The triangle would look quite different from the original sketch, but it does match all of the information given in the problem. So there are two possible triangles that could have the given information. Find x, round to the nearest tenth. We're solving for the side opposite the 65-degree angle. Since we don't have another angle for the law of sines, we use the law of cosines. X squared equals the sum of the squares of the adjacent sides, 9 and 17, minus twice their product times cosine of 65 degrees. 9 squared equals 81, 17 squared equals 289, minus, multiplying 2, 9, and 17, we get 306 times cosine 65. Using a calculator, we get x squared is approximately 240.68. Finally, take the square root of both sides. X is about 15.5 to the nearest tenth.